Hello, I'm Li Hao. Welcome back to Evan of Code 2023. We are solving puzzles with code every day until the Christmas day, and today we are on day 5. 1, 2, 3, 4, 5. So, what is this puzzle that we have for day 5? Let's take a look. So, day 5, if you give a seed a fertilizer, you take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more like you like a farm. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we have to stop the water because we ran out of sand to filter in with. Can't mix snow with dirty water. Don't worry, I'll make sure that we'll get more sand soon. We only turn off the water a few days, weeks. Oh no! His face sinks into a look of a horrified realization. I've been so busy with making sure that everyone here has food that I completely forget to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when it brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island almanac has just arrived and we are having trouble making sense of it. The almanac, which is your puzzle input, lists all the seeds that you need to be planted. It also lists what type of soil to use with each kind of seed, which type of fertilizer to use for which kind of soil, which type of water for which kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but the numbers are reused by each category. So the soil 1, 2, 3 and the fertilizer 1, 2, 3, aren't necessarily related to each other. This is the example of the almanac. Okay, you have the soil to fertilizer, fertilizer to water, water to light, light to temperature, temperature to humidity, humidity to location. And the almanac starts by listing which seeds you need to be planted. Seeds 79, 14, 55, and 13. So the rest of the almanac contains a list of maps which describes how to convert numbers from a source category into numbers into the destination category. That is, the section that starts with the seed to soil map describes how to convert a seed to a soil. This lets the gardener and his team know which soil to use with which seeds and which water to use with which fertilizer and so on, right? So you have seed to soil, soil to fertilizer, fertilizer, water, water to light, light to temperature, temperature to humidity, humidity to location. Okay, wow. Okay, so rather than a list of every source number, it corresponds to destination number one by one. The map describes entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: destination range, source range, and the range length. So consider this, right? Destination range starts with 50, source range starts with 98, and the range length of 2. This line means that the source range starts with 98 and contains 2 values, so 98, 99, okay? Destination range is the same length, so 50 and 51. With this information, you know that the seed range 98 corresponds to soil 50 and the 99 corresponds to 51. Okay, so it has the same number of the range is the same, and so you start mapping from 98 to 50 and then for 2 numbers, so 98 to 50, 99 to 51. Second line means the source range starts with 50, right, and contains 48 numbers, and then this corresponds to destination range as 52. So for 50, you go to 52, 51, you go to 53, and so on and so forth for 48 numbers. Any source numbers that aren't mapped corresponds to the same destination number. So because we're mapping from 50 all the way to 50 plus 48, which is 97, right? So there's 48 numbers. We're going to map from 50 to 97 and also 98 to 99. But for those numbers that aren't inside, like number 10, it corresponds to number 10, right? No mapping at all. So the entire list of seed numbers mapping, it looks like this. And with this number, you can look up the soil number required for each initial seed number, right? So 79 maps to 81, 14 maps to 14 because no match, 55 match to 57, and so forth. The gardener and his team wants to get started as soon as possible, so they like to know the closest location that needs a seed. Using these maps, the lowest location number corresponds to any of the initial seeds. To do this, you need to convert the seed number through other categories until you can find the corresponding location number. So you can, from seed you map to soil, soil map to fertilizer, fertilizer to water, water to light, light to temperature, humidity, and location. Okay, so here are the list of locations that we map to. So what is the lowest location number in this example? And this is 35, and this is the answer. So what is the lowest location number that we need to find based on our initial seed number? Wow, that's so complex. Okay, so we have seed to soil, soil to fertilizer, fertilizer to water, water light, light to temperature, temperature to humidity, humidity to location. This is the mapping. And then these are our initial seeds, and we are going to solve this. We're going to first start to parse this out, and then we're going to build some way to process this range. Maybe we're going to create some data structure to store this information. So next time when we find something, we can easily know how to map it. And then we're going to map to soil, to fertilizer, to water, light, temperature, and then all the way to location. Okay, so let's copy this. No, let me, instead of being so confident and process the number immediately, let's copy this input, example input over here, and then we see whether we can do it right with this. We can get the same answer as the example. Okay, so let's go to our code. Okay, so let's create a new data, day 5 puzzle 1.js, and this is our input. So if you want the code here, I have pushed to my GitHub, and the link of the source code is also in the description. So if you want to see how the final code look like, you can go there and take a look. So here, const inputs, this is the almanac, the instructions. So first is we are going to, same thing as what we have done previously, we're going to split into lines. So input.split lines. And we are going to pass through and process them line by line, and then we are going to store the information that we need. Okay, so I think this is sort of in order. I think it's much easy. We can ignore this mapping because it's seed to soil, soil to fertilizer, fertilizer water, water to light, light to temperature. We don't have to, we can ignore this line, I feel. We don't have to parse out whether what maps to what, since it's sort of like sorted in order for us. And I think it was the same thing as well. Seed soil, fertilizer, fertilizer water, water light, light temperature, temperature humidity, humidity location. So it is in order. Okay, so I think for categories we don't have to parse this. So we figure out how to get this number, and then we encounter some sort of like when we have run into a new line, and then next line is a category header. We can ignore it, and then we parse the range until we reach a empty new line, and then we will know we are in the next category, and then we just keep doing it until we hit the end of the lines. Okay, so here first thing is we're gonna get the seeds, right? So seeds, we can ignore this. We can get all the numbers that we can encounter in this line. So the initial seeds equals to lines. I'm gonna create a variable called line number 0, and this is the line number dot match all, gonna match all numbers, and we are going to spread it out so that we get returns. This returns us, the match all returns us an iterator. We're gonna spread it into an array, so we convert it into an array. If you don't like writing it this way, you can also write array.from. It's up to you, but we're gonna just do the spread, and then after we spread it, we are gonna take out the first, the match of each matches, right? So each the array, each element in the array of the match all is a match. A match contains is also an array of telling you what is the what's the string that's matched, also a list of capturing groups. So we're gonna get the match. That's all. We're not using any capturing group. So the first element is a number. Return that number, and then this will gives us the initial sits. And then we're gonna convert it to number as well. Right, this is number in string, and then we convert number to the number data type. Oops, sorry. Okay, so here, after we get our initial seeds, next thing is we're gonna reach, I think this one can increment. We're gonna skip the new line, and we are in this phase where we are at here. We're gonna go to loop through a category and then map the numbers until we hit a new line. Right, so here, I'm gonna create an array mappings. This array will, once we loop through this, we're gonna store them in these mappings. Okay, the result of parsing a category into this mapping. So this is the mappings that we can call to figure out like what is the mapping from one category to another category. So here we are going to loop through lines while line number less than lines.length and line number, no, I think, yeah, while it's less, then we just keep looping. Line number plus plus, because we are hitting a new, we are ignoring this line, and then we can just keep parsing this. And while lines of line number while it's not empty, we're gonna loop. So this is the line, and then of course we need to remember to increment at the end of the iteration. And for each line, we actually have 3 numbers separated by spaces, right? So we can actually use the split, line.split with space, get 3 number, destination range. Sorry, destination, what is it called? Destination range start, source range start, and the range. I'm gonna split and also gonna map it with as number, right? The number. Split and map it to number, and then we have 3 numbers over here: destination range start, source range start, and range. So we need to figure out way to process to store this somewhere, and then we're gonna put it into the mappings. So here, what I'm gonna do is I'm gonna create a data structure so that we can keep a list of all this. Do I need to have a data structure? Let me think. Yeah, I'm gonna create a simple object over here, matcher, called matcher, and the mappings again I'm gonna call is an array. sorry, not matcher, mapping, range mappings. And then I'm gonna push this mapping dot range mapping dot push the destination, the source, and then also the range itself. Okay. And then after we parse, and then we encounter we keep looping until we reach a white line, new line, empty new line. Then we are going to increment until we reach the next category header, and we are continuing a big loop. And before that, we need to remember to push this thing into our mappings. Right, mappings are push mapping. I think we can do it here as well. Once we create, we can just push it in. And then we should have all our mappings now. So with the mappings, now we need to go with each of the initial seeds, and then we're gonna map out and then figure out what is the final location of the seeds. So for the seed of initial seeds, the last thing we need to know is the lowest location number, right? So this is the lowest location. I'm gonna initialize it with positive infinity. So that if it's less than this, we're gonna update the value. And in the seed, so what we need to do is for each seed, we are going to loop through the mapping. Right, each mapping is actually a range mapping over here. Okay, I think instead of an object, let's just make it the array directly, like this. So each of this mapping is actually an array as well. Okay, so this is the range mappings of range mappings. It's an array as well. So this one gives us actually what we have inside is the destination, the source, and the range, right? So we have the source, range start, destination, range start, and the range. So we're gonna find what is the mapped value of the initial seed. So here, the map location equals to the seed. So the initial, let's initialize it. The mapped final location is the same location where the seed is, the same number. And then for each mapping, we're gonna map it to a new number, and then we'll keep doing it. Right, and then for each of the map, we need to go through and check whether, for example, if the map, if this is the result. Okay, I think it's a bit confusing. Call map location. I'm gonna call the map value. Okay, so the mapped value, if this initialized as a seed, and if we keep mapping, right? If this value is greater than the source range, and map value is less than the source range start plus the range. So basically, it's within the range of where we're gonna map, right? It is greater than source range and less than the source range, less than source range plus the range. Then we know we need to map it to based on the destination range start plus this thing, right? So map the value equals to destination Whoops, destination range start plus the difference between the source to the destination, right? So for example, over here, this is the source, this is the destination. So the difference is 98 minus 50, right? Which is 48. So for if it's at here, we need whatever value that we get, we need to minus 48 to get 50. And 99, we need to minus 48 to get 51. So here we're gonna minus off the source minus the destination range start. Okay, so source range start is 98 minus the destination, which is 50, which is 48. So we're gonna minus that off. The current value must minus off this thing, right? So it's actually equals to this one. Map value minus off this. And once we figure out that we can map it, we can actually break off this loop and then continue to the next mapping, right? We're gonna break it off. Gonna faster and go to the next mapping. And next mapping, we're gonna just keep mapping until we get the final mapped value for the seed. And then here, we go through all level of mapping from the seed to soil, soil to seed to soil, soil to fertilizer, fertilizer, water, temperature, all the way to location. And then this mapped value is actually the location value where the seed is mapped to. So now what we need to do is that if mapped value is less than the lowest location, I'm going to update it. Lowest location equals to mapped value. And finally, we console out the answer and see what we get. Okay, I think that is it for the solution. And let's run this. Day 5, puzzle 1. I'm get 35, which is the same as over here. So I think we are on a good trajectory. We are on a good direction. I think our solution is correct. So let's try to run it with the actual input instead. Okay, this is the actual input. It looks huge. Let's see whether it works as well. I'm gonna run this, and then we get this number. I'm gonna copy. I'm gonna come here. I'm gonna paste it in, and hit submit. And yes, that's the right answer, and we get 1 gold star. We are on the part 1 of day 5. We've had 1 gold star, and we should go forward to get our 2nd gold star for day 5 and continue to part 2. Wow. Everyone will starve if you only plant a small number of seeds. Reading the almanac, it looks like the seeds, the line actually describes the range of seed numbers. Okay, we read it wrongly. The values of the initial seeds line come in pairs. Within each pair, the first value is the start of the range and the second value is the length of the range. So in the first line example, we get the range. This line describes 2 ranges of seed numbers to be planted in the garden. The first range starts with seed number 79 and then contains 14 values. So this, and the second range starts with the seed number 55 and contains 13 values. Here to here, rather considering 4 seed numbers, you need to considering 27 seed numbers. In the above example, the lowest location number can be obtained from the seed 82, which corresponds to this, 46. So the lowest location number is actually 46. Consider that all the initial seed numbers listed in the range of the first line of almanac. What is the lowest location number that corresponds to any of the initial seed numbers? So we're gonna change the logic a bit on how we're gonna loop through the initial seeds to get the final map location. But I think should be okay. I think the only concern is that there will be a lot of seeds over here and it will take a while for us to loop it through if we just do this naive implementation. But let's take a run and see how far we can go from here. Okay, So here for we're gonna get numbers in 2 pairs, right? So let's see. At I equals to 0, I less than initial seeds dot length, I plus equals to 2, right? I'm gonna loop in 2, and then we have the actual seed number, initial seeds I, and the the starting is initial seeds I, and the range is actually initial seeds I plus 1. So we are gonna start from here, and then we can count it up. So I have created another variable called counter. Start with 0, and then we loop until the counter is less than range, and counter plus plus, as well as our starting plus plus. Sorry, no, the seed plus plus. And then here we have our code, and let's run and see whether this is as efficient as it can. It will take a while. Yeah, it will take a long. Oh, hold on. This is puzzle 1. Wait, we changed the code for puzzle 1. Let's replace this. Okay, so we should be running puzzle 2, and we changed the code for puzzle 2. Puzzle 1 should be as fast as it was. Puzzle 2 is something that it will take a while because we go through every seeds, and then we're gonna find the range for each of the seeds. We're gonna find the mappings of each of the seeds, and the range of the seeds we are getting is crazy. It's so many numbers, and it does not make sense if you're gonna iterate through one by one to figure out what is the value of the mapped location for each of the seeds. Okay, so this is definitely not efficient, and we need to figure out a way to solve this. Let's think about it. While it's running, let's think about it, and then maybe by the time we finish thinking, it's give us an answer, then we don't have to really write it out, but let's think about it. Okay, so from here, so I think what we need to do is that for this range, we need to figure out what is the mapped range, right? So starting from the starting number to the ending of this, we need to know the mapped range for the seeds, right? So for example, 79 and 14 numbers, so we have 79 to 82. We need to know the range of how it will map to, and that mapped could be splitted out and mapped to even more ranges. But then at least we know that 79, whether what it is within, it probably is within 50 to this. We're gonna map it to a new range of numbers, right? Yeah, so we get a new range of numbers. So probably we get maybe 4 from these 2 ranges. We probably get mapped to 2 more ranges, or could be 3 or 4 more ranges based on this after one mapping. And then with that 4 ranges, we're going to continue to go through another mapping and then see what new ranges that we're going to get. And then with all these ranges, we keep going and map it through, and then we will get to the final ranges, and then we get the minimum value of the ranges that we finally get. Okay, I think that's the rough idea that we're gonna do instead of going through each seed by seed. So here we are gonna kill this process and gonna come back and implement this. So I think let's start with a simple example case first, so that we know we are our implementation is correct, or we are on the right track. So this is the seed, and then this is the initial seed numbers, line numbers. Okay, so first thing is that one thing I want to do is that after we get this range mappings, I want to sort it. Okay, I want to sort the range mappings. The reason of sorting is because that so that we always the source is the starting point of that range that we get. The ranges mappings that we have is in order of the source range starts. So that we know when we have a range that we want to map to a new range, we know we can start from the left to the right and of this range mappings array. And once we reach way beyond the range that we want to map, then we know that we can stop and we can early end this looping. Okay, so to do sorting, we can write our custom sort function. So it's still using the array.sort, but this gives us a callback and tells us the we can return a number that tells the array.sort on how to sort this, right? So we're gonna sort in order for the based on the source range starts, which means that we're gonna return a.source range starts minus b.source range starts. So if you have a minus b is always in order, it's ascending order. If you the other way around, where b minus a, then it's a descending order. So we have sorted in ascending order now, and then so we have this range mapping sorted, and for all the initial seeds, the starting. Okay, we'll rename this seed start range, and then a range. Okay, I'm going to create an array, ranges over here, and then ranges dot push the seed start range and the range, or rather the range. We're gonna say the seed start range plus range minus 1. So it's inclusive. Our range is inclusive, and push into the range, and then we end this loop. So here we have an array of ranges, and what we're gonna do is that let I'm gonna loop through the mappings, and every turn we create a new ranges array, and then we're going to map the ranges into this new ranges array. And at the end of the loop, we are going to say ranges equals to new ranges, right? Range for each new range, if mapping, we create a new range, and then we're going to set it, and then we can figure it out what's the new range, and then we assign it back. And then at every loop, we just keep doing this. And at the end, what we need is that for to get the lowest location, what we need to calculate is that for const range of range, if range, the first number is a starting, second number is a ending, right? If this is less than the lowest location, then range, the lowest location equals to this, right? And that's it. And then this is the answer that we're going to get. And this is the thing that we're going to print out. So here, we're going to figure out how to implement this part. For new range, so of course, we're going to base on what is the range that we have to start and the end, inclusive of range. And then we're going to see what we're going to map it to, right? So if So here we're gonna go through the range mappings and then see where we're gonna map it to. So we're gonna find a range that we are in, that includes our starting point first, right? So let I index equals to 0, while you know what? I think we can also slightly optimize this by sorting these ranges as well, from ascending order. So this is A and B. So A, the first item, minus B. So this gives us ascending order based on the first element for this, the range A and range B. And I'm going to do this over here as well. Oh, never mind. I think after I assign, I will just do this over here. And so that we know that as you look through, the starting is always the smallest, right? And if we are doing that, actually, which means the answer will always give us the lowest location is gonna be the range, the first range, and the starting of the first range, right? Because we have to sort it and figure out the lowest location of it. So here, so index is the index for the range mapping. I'm gonna go through once and that's it. So index of the the index of the is less than range mappings length. We are, let me see, while index is less than the range, actually no. So if we know that okay, so right now we are, if the starts is less than the range mappings index, dot source. So there's a few situations, source range starts, right? If this is less, okay, if the ending is less, so which means that start end, and then we have numbers, and then we have the source range start, and then we have this thing, right? If this is the case, right? If this is the case, then this start and end maps to itself. Right? So which means that the new range we're gonna push the same thing start and end in to the array, and that's it. And then we go on to the next range. And else, if we are in a situation where we have start is here, right? And then we have the source range start, and then we have the destination until the range map range end, and then we have the ending. If it's something like this, right? So basically we have a few situations, right? So one is this, one is this, the end is inside here, and then another one is the start end is completely within and could be start and is outside. Okay, so I think I need a few things. First is this is going to be the mapping index. And we also need a range index. And the range that we're looking at is actually the range index. And we're gonna loop while range is defined. And the start and end is equal to the range. We destructure the range to get the start and end. Okay, the reason I'm taking it out as this and instead of doing the loop is that I realized that if the ending is beyond the map range end, in this case, in both cases like this, we actually can split this current range into another new range that is starting from the map range end, right? We can split it out, and then we use this new range that we split it out like this part, to look at the next range mapping and figure it out. So we're gonna, we are gonna treat it as we just split the range into the source range into two more range, into two range, and then the second half of the source range, we're gonna go through this same loop again to find the mapping of the in the range mapping, right? I think this is what I'm gonna do. So, so here, if it so here I think what we here is based on the situation where we're gonna handle this too, and then at the end of the as the same thing, and handle this too as similar, I think. Let's see. Yeah, so if I do this first, if the start is greater than source range start, hold on, this is this part. If it's greater or equal to the source range start, so the new range start is equals, and we need to map it, right? It's the new range start is going to be the start plus I think we have this before, is equals to this value minus of hold on, let me think. Oh, I think we didn't consider a case where start is over the map range end, right? So let's start with that first, because in that case we just need to continue the loop again. If the start is greater than range mapping index dot source range start plus range is greater than this greater equal to this one, then actually it's a different range, and we don't need to do anything with this. This one we are going to increment the mapping index plus plus, and continue the loop. Right, else if. Okay. So in this case, the start is greater, and then we have make sure that it is within the range. So we are going to minus off this part, minus off this source range start, minus the destination range start. This is the new range start. And for the ending, let new range end. It depends, right? Because the ending could be beyond or within the range. If it's within the range, then we are going to have the then we have the full mapping of the start and the end mapping. But if it's beyond the range, then we're gonna cut off from the range for the starting and ending, and then we're gonna so it's like splitting it up into two range, right? The current range will split into the start to the end of the source range, and then the new range will be starting from the source range ending to the current end. Okay. Maybe it's a bit abstract, but let me write it out and let's take a look at how it looks like in terms of code. The condition is that if the new range, if the end is less or if it's less than equal to the source range start plus the range, right? If it's less than equal of that, then we are not gonna split the range, right? So the new range n is exactly how the range mapping index dot destination range start plus this one. Wait, hold on, not plus this one, plus it's the same thing, same calculation over here, right? This one, this calculation, but applied for end. Right, and in this case, we have the new range start, new range end, and the range, the next range that we're gonna try and check will be based on the next range index. Hold on, let me think. I think we don't have to do that. Equals range index. Yep. Let's update it. Range equals range index. We'll start with 0, right? And so it should be already moved plus. Yep, +1, and this is also plus plus. Over here, that's right. And over here, if it's beyond the ending, then the new range n is gonna be it's going to be the destination range start plus the range, right? So it's gonna be mapped to the last value of within the range, and then range, and then we're gonna create a new range out of it, which is gonna be at the starting is this one +1, and the ending is the same. And so it's like we are splitting it into a next range, and we use this range to go and figure out whether what's the to figure out the mapping, right? Okay, I think range starts. Hold on, let me think. I think we might be having some off by one kind of situation. This is less than, not equal, and then the range n over here, we're gonna add this should be -1. I think this is not, this is like this. So we have the new range to figure it out, and we don't have to worry about the mapping index, because if we find the next one that the start is beyond the current one, then we'll increment the mapping index when we continue the same loop with the same range and look at the next mapping, right? This part, new ranges, push the start and end. Then in this case, our range should be updated to be the range index plus plus. Okay, so not all of the conditions we're gonna increment to find the next range. This one is the current range. It's not within the boundary of the mapping, it's beyond. Then we're gonna increment this and find the next mapping. This one, we already pushed this thing in, so we're gonna use the next range. And then if here, in this case, it's either this situation where the ending is less than the map, the start and end is within the range, so we able to get the new range, start and end, and then the range is moving up. Go to the next ranges, and then if not, we're gonna split it out, and so we don't increment, we don't not looking at the next range, but rather that we split it out and we create a new range and try to find a mapping for that instead. And in this case, for both cases, we already have the new range start and end, so we're gonna push it to the result, which is the new ranges over here. For the new range start and new range end. Okay, I think it's a bit confusing now. But let's quite try to finish out the last condition. Over here, the condition is that if the start is less than the range mapping index dot source range start. Actually, if this is true, this else if is a bit kind of redundant. The reason is also that the end, we know that the ending is always greater than the source range map because we have this condition first, and right, so we know that this is either start, the source range start. In both cases, it has to be these two cases are probably mutually exclusive, I guess. But let's see. So here, we are before this one, so which means that we probably need this. We're gonna probably the starts to the source range start is a range that we don't have a mapping for. So the new ranges is actually equals to push start to the range mapping index the source range start source range start -1, and then the range we're gonna split it up is equals to the range mappings, mapping index, source range starts, starting as this one, ending is the same ending, and then we're gonna look for the mapping for this new range instead. Okay, it sounds like we're done with our code. Hopefully this makes sense, but let's try and run and see what we get. Yeah, obviously we run into errors. So this is reading properties on undefined range mappings. Mapping index is not line 84. So it seems like we might be running into situations where the starting is beyond the range mappings, and we run out of range mapping. And in that case, so maybe let's add another condition before this one. If mapping index is greater equals to range mappings dot length, right? In this case, we are beyond what we can find in the mapping. Then basically any range that we have, we just map to itself, right? So new ranges dot push starts and end, and then range equal, just look for the next one, right? So don't worry that we might go out of bounds, because what it means is that our ranges will be undefined, and we will exit our loop when we hit undefined. Save this and try to run and see whether this fixes this problem. Okay, it's not returning, then probably we are running into some infinite loop. So let's kill from here, and let's take a look at, let's probably try to guess and where we stuck at, right? So first of all, we're gonna console log the maybe loop over here. Just see how many times we pass through this loop. 2 times. So I think we stuck at the second loop. Okay, so maybe let's before we go to that, let's take a look at, since console log the ranges that we have, and let's run. So we start with 55, 67, 79, and 92. Okay, is that correct? Sorry, my brain foggy now. We have 55 to 67 and 79 to 92. Okay, sounds about right. And we are gonna map, go through the first mapping. Right, so first mapping is, let's see whether this shows. $25 to 67, right? Yes. And then now rather considering state number equals there, above the lowest location. Okay, it doesn't say, but okay, let's step through and take a look whether we at least we get this correct, right? So the next one is we have to 55, the mapping 55 is plus 2, right? This mapping will go up, so plus 2 plus 2, this range sounds about right. And 79, it's still within the range for this one, so it's still plus 2. 92 is still within range, so plus 2, so 57, 69. Okay, 81, 94. And then we're going to map through here, this mapping. Okay, and then we are stuck. So maybe let's see which range or where we are stucking at. Range over here. Let's try and print out. Seems like 8194. When we are at 8194, we are stuck. So 8194 seems like it's not part of any range. So the start Hold on. Oh, this one has to be plus plus. Right. Okay, we get 46. Lowest location number is 46. It looks promising. Okay, it looks promising, and also you can see that we actually slowly we split it to more range, right? Because we are yeah, because some of the range it overlaps with other ranges, so we split it out. So it seems promising. Let's just try our luck and print. Let's get the source, the puzzle input, and let's put it in over here. Save this and let's try and run. We get this number. Sounds promising. Let's go in. Let's paste it in and hit submit. And we get the right answer. Yay! Wow, this is a harder gold star that we have done over the past 5 days. This is definitely something for a celebration. And let's take a rest. And we are going to go on for the next puzzle for day 6. So we have 10 stars in our belt. We are heading to day 6. And I shall see you in the next video. So, hey, see you. Bye bye.